How often do you think about your heart health? Are you aware of the risks of cardiovascular disease? Well, let's dive into the heart of the matter. Cardiovascular diseases, encompassing coronary heart disease and stroke, claim the top spot as the leading cause of death in the United States. Particularly at risk are blacks and Hispanics in underserved communities. It's a sobering reality, isn't it? But there's good news. Cardiovascular disease is largely preventable. Stay tuned to learn how you can keep your heart beating strong. Heart Smarts, a health program, is here to empower you to live a heart-healthy lifestyle. This program is not just about information, but about transformation. It offers a comprehensive approach to help you understand and achieve heart health. Heart Smarts is committed to reducing the incidence of cardiovascular disease, the leading cause of death in the United States. The program focuses on underserved communities where the risk of heart disease and stroke is greatest. Through education and empowerment, Heart Smarts aims to turn the tide on these statistics. It's a call to action, a call to change, a call to live healthier, longer lives. Heart Smarts is about arming you with the knowledge and tools you need to make heart-smart choices every day. It's about the power of prevention and the promise of a healthier future. Remember, Heart Smarts is not just a program, it's a life-changing journey. It's about taking control of your health, one heartbeat at a time. But don't just take our word for it. Listen to these stories from people who have benefited from Heart Smarts. Imagine being told you're at risk for heart disease, a leading cause of death in the United States. Now picture having the knowledge and tools to combat that risk head-on. For people like Maria, a single mother from an underserved community, Heart Smarts was a beacon of hope. The program informed decisions about her heart health, ultimately reducing her risk of cardiovascular diseases. And then there's John, a middle-aged man who was once a prisoner of his poor lifestyle choices. For him, Heart Smarts was not just a program, but a lifesaver. It opened his eyes to the risks he was taking and gave him the push he needed to commit to a healthier lifestyle. These are not just testimonials, they are life-changing stories. Stories of empowerment, resilience, and triumph over heart disease. These are real stories from real people who have seen the impact of Heart Smarts in their lives. Are you ready to be the next success story? Your heart health is in your hands, and with Heart Smarts, you have the power to make a difference. It's time to take that first step towards a healthier lifestyle, a step that could redefine your future. Heart Smarts is not just an ally, it's a beacon, guiding you to make informed decisions for your heart health. So why wait? The path to a healthier heart is just a click away. You'll find the link to Heart Smarts right down in the description below. Start your journey towards a healthier heart today with Heart Smarts.
Ladies and gentlemen, today, I stand before you to discuss a material that is often overlooked in our daily lives yet has played a pivotal role in shaping our civilization, paper. It may seem mundane, ordinary even, but paper is a remarkable invention that has profoundly impacted human history, engineering, and physics alike. First and foremost, let's delve into the engineering marvel that is paper. Paper making is an intricate process that involves transforming plant fibers, primarily from wood pulp, into thin sheets of material. The engineering behind this process has evolved over centuries, from ancient techniques using manual labor to modern industrial methods incorporating sophisticated machinery. In the early days of papermaking, artisans relied on simple tools such as mortar and pestle to grind plant fibers into a pulp, which was then mixed with water and poured onto flat surfaces to dry. This rudimentary process required significant manual labor and was limited in its efficiency and output. However, it laid the foundation for the development of more advanced papermaking techniques. As societies progressed, so did the engineering techniques employed in papermaking. Innovations such as the water-powered paper mill revolutionized the industry, allowing for increased production and efficiency. Engineers designed elaborate systems of water wheels, gears, and pulleys to power the machinery needed for pulp processing, sheet formation, and drying. The introduction of the Fourdrinier machine in the early 19th century marked another milestone in papermaking engineering. This continuous papermaking machine automated the process of forming paper sheets, leading to significant increases in productivity and quality. Engineers refined the design of the Fourdrinier machine over time, incorporating features such as vacuum systems and precision controls to achieve precise paper properties. Today, papermaking is a highly sophisticated industry that employs cutting-edge technology and engineering principles. Advanced pulp refining techniques, such as high-pressure homogenization and enzymatic treatments, allow for precise control over fiber properties and paper quality. Engineers utilize computerized process control systems to monitor and optimize every aspect of the papermaking process, from raw material preparation to final product finishing. From an engineering standpoint, the papermaking process involves the application of principles from various disciplines, including fluid mechanics, heat transfer, and materials science. Engineers analyze the flow of pulp through pipelines and screens, optimize drying conditions to minimize energy consumption, and develop novel materials and coatings to enhance paper properties. On the physics front, the study of paper involves investigating its mechanical, optical, and thermal properties. Physicists employ techniques such as atomic force microscopy to probe the nanoscale structure of paper fibers and characterize their mechanical properties. They study phenomena such as the drying-induced stresses in paper sheets and the diffusion of ink into paper substrates to understand and optimize printing processes. In addition, physicists investigate the optical properties of paper, including its reflectance, transmittance, and scattering behavior. These properties play a crucial role in the appearance and printability of paper and are essential considerations in applications such as photography, printing, and packaging. Physicists use sophisticated modeling techniques to simulate light interactions with paper surfaces and develop predictive models for optimizing print quality and color reproduction. Overall, the engineering and physics of papermaking represent a fascinating intersection of science, technology, and innovation. Through continuous advancements in materials, processes, and technologies, engineers and physicists continue to push the boundaries of what is possible in papermaking, driving progress and sustainability in this essential industry. The design and optimization of papermaking equipment require a deep understanding of fluid dynamics, thermodynamics, and materials science. Engineers have developed intricate systems of pulping, refining, and drying to efficiently produce paper on a massive scale. They've devised methods to control the properties of paper such as strength, thickness, and porosity to suit various applications, from newspapers to packaging materials. The history of papermaking is rich and diverse, tracing its origins back to ancient civilizations such as China and Egypt. The earliest forms of paper were crafted from natural materials like papyrus and silk, demonstrating humanity's ingenuity in utilizing available resources for communication and record-keeping. Over time, advancements in engineering and physics have revolutionized the papermaking process, enabling the mass production of paper and expanding its utility across countless industries. In the realm of engineering, the optimization of papermaking equipment involves a delicate balance of efficiency, cost-effectiveness, and environmental sustainability. Engineers employ principles of fluid dynamics to design efficient pulp processing systems that minimize energy consumption and waste production. Thermodynamics plays a crucial role in controlling the temperature and humidity during the drying process, ensuring uniformity and quality in the final product. Additionally, materials science informs the selection of raw materials and additives to enhance the properties of paper, such as incorporating recycled fibers for sustainability or introducing chemical treatments to improve strength and durability. From a physics perspective, the behavior of fluids within papermaking machinery is governed by complex phenomena such as turbulence, viscosity, and surface tension. Physicists work alongside engineers to model and optimize these processes, using computational fluid dynamics simulations to predict flow patterns and optimize equipment design. Moreover, the mechanical properties of paper, including its tensile strength, elasticity, and tear resistance, are subject to rigorous analysis and experimentation. By understanding the underlying physics of these properties, researchers can develop predictive models and design criteria to tailor paper formulations for specific applications, from lightweight newsprint to heavy-duty packaging materials. Throughout history, paper has been a catalyst for cultural exchange, education, and innovation. Its widespread availability facilitated the dissemination of knowledge and ideas, fueling the Renaissance and Enlightenment periods. Today, paper remains an essential medium for communication, despite the digital revolution. As we continue to advance in engineering and physics, let us not forget the humble yet indispensable role that paper plays in our lives and the myriad opportunities it presents for exploration and discovery. Moreover, paper engineering extends beyond manufacturing processes. It encompasses the structural design of buildings, bridges, and other infrastructure that rely on paper-based materials such as cardboard and laminates. Engineers leverage the unique properties of paper to create lightweight yet sturdy structures, contributing to sustainable construction practices. In the realm of engineering, the use of paper-based materials for structural applications has gained traction due to their renewable nature and low environmental impact. By employing techniques such as folding, weaving, and laminating, engineers can tailor the mechanical properties of paper to meet specific design requirements. This approach not only reduces the carbon footprint of construction projects but also offers innovative solutions for challenges such as lightweighting and prefabrication. From a physics perspective, the behavior of paper-based structures presents intriguing phenomena that are ripe for exploration. Physicists investigate the mechanical properties of paper composites under various loading conditions to understand how they deform and fail. The hierarchical structure of paper, comprising microscale fibers bonded together at different levels, gives rise to complex mechanical responses that defy simple analytical models. Through experimental testing and computational modeling, physicists seek to unravel the underlying physics governing the deformation, fracture, and failure mechanisms of paper-based materials. This fundamental understanding not only informs the design of more resilient structures but also contributes to the broader field of soft matter physics. The history of paper engineering is intertwined with the evolution of human civilization, dating back to ancient times when early societies crafted rudimentary paper from plant fibers. Over millennia, the art of paper-making spread across cultures and continents, leading to innovations in manufacturing techniques and material science. In the modern era, advancements in engineering and physics have propelled paper engineering to new heights, enabling the creation of sophisticated structures and materials that were once unimaginable. As we look to the future, the legacy of paper engineering continues to inspire us to push the boundaries of what is possible, driving progress in sustainability, innovation, and human ingenuity. Now, let's turn our attention to the physics of paper. At its core, paper is a composite material composed of cellulose fibers bonded together by intermolecular forces. Understanding these forces is essential for predicting the mechanical behavior of paper under different conditions. From an engineering standpoint, the manipulation of these intermolecular forces is crucial for enhancing the properties of paper. Engineers employ techniques such as surface treatment and coating to modify the surface chemistry of paper, improving its printability, water resistance, and durability. By controlling the interactions between cellulose fibers and additives, engineers can tailor paper to meet specific performance requirements, whether it's for high-speed printing or long-term archival storage. In the realm of physics, the study of paper's microstructure offers insights into its mechanical properties. Physicists utilize microscopy and imaging techniques to examine the arrangement of cellulose fibers within paper matrices. By understanding the hierarchical organization of fibers at different length scales, physicists can elucidate how mechanical stresses propagate through the material, leading to phenomena like buckling, wrinkling, and delamination. Furthermore, historical perspectives shed light on the evolution of papermaking technologies and their impact on society. The invention of paper dates back to ancient China, where it was initially made from mulberry bark and hemp fibers. Over time, advancements in papermaking spread across civilizations, from the Islamic world to medieval Europe, fueling the dissemination of knowledge and cultural exchange. The transition from handmade paper to mechanized production during the Industrial Revolution revolutionized the printing industry, paving the way for mass communication and literacy on a global scale. In modern times, engineering innovations continue to drive the paper industry forward. Sustainable practices such as recycling and eco-friendly pulping methods have become paramount in reducing environmental impact. Engineers and physicists collaborate to develop cutting-edge technologies for waste reduction, energy efficiency, and alternative fiber sources, ensuring the longevity of paper as a versatile and sustainable material. In essence, the interdisciplinary nature of paper science encompasses both engineering ingenuity and physics principles, intertwined with a rich tapestry of historical significance. By synergizing these perspectives, we can unlock new frontiers in paper technology while preserving its cultural heritage and environmental integrity. Physicists delve deeper into the mechanical properties of paper through various experimental techniques. One such method is tensile testing, where a sample of paper is subjected to controlled stress until it reaches its breaking point. By analyzing the stress-strain curve obtained from these tests, physicists can determine crucial parameters like Young's modulus, which quantifies the material's stiffness. This understanding aids engineers in designing paper products with optimal strength-to-weight ratios, crucial in industries such as packaging and aerospace. Moreover, physicists investigate the intricate physics behind everyday phenomena like creasing, tearing, and folding. These seemingly simple actions involve complex interactions between cellulose fibers and the forces acting upon them. By studying the mechanics of creasing, physicists gain insights into how paper deforms under localized stress, essential for designing efficient folding and packaging techniques. Similarly, understanding the dynamics of tearing provides valuable information for enhancing tear resistance in paper products, crucial for applications requiring durability. In addition to mechanical properties, physicists also explore the thermal and acoustic characteristics of paper. Thermal conductivity, for instance, influences the insulation properties of paper-based materials, impacting their suitability for applications in buildings and electronics. Acoustic absorption is another area of interest, where physicists investigate how paper-based materials can attenuate sound waves, contributing to noise control in architectural designs and automotive interiors. Furthermore, the history of paper is a testament to human ingenuity and technological advancement. Originating in ancient China over 2 millennia ago, papermaking spread across the world, revolutionizing communication, education, and commerce. The evolution of papermaking techniques, from handcrafted methods to mechanized production, reflects the continuous quest for efficiency and quality. Understanding this history not only provides context for modern paper engineering but also underscores the cultural and economic significance of this ubiquitous material. The optical properties of paper have fascinated physicists and engineers alike for centuries. From the earliest days of papermaking to the present, understanding how light interacts with paper has been crucial for improving its printability and durability. In the realm of engineering, advancements in digital printing technologies have relied heavily on our comprehension of these optical properties. Engineers have developed sophisticated printing systems that leverage our understanding of light reflection, absorption, and scattering to produce high-quality prints on various types of paper substrates. In the realm of physics, researchers delve into the intricate physics behind light-paper interactions using techniques such as spectroscopy and imaging. These methods allow physicists to analyze the microscopic structure of paper and how it influences the propagation of light. By studying phenomena such as surface roughness, pigment distribution, and fiber alignment, physicists can gain insights into how to optimize paper for specific optical applications. Moreover, the history of paper itself is intertwined with engineering and physics. The ancient art of papermaking, originating in China over 2,000 years ago, was a testament to human ingenuity and scientific curiosity. Early papermakers experimented with different plant fibers and processing techniques, laying the foundation for the modern paper industry. Over time, advancements in engineering and physics have revolutionized the papermaking process, making it more efficient, sustainable, and versatile. Today, the interdisciplinary nature of paper research continues to drive innovation in both engineering and physics. Engineers are exploring novel paper-based materials for applications ranging from flexible electronics to biodegradable packaging. Physicists, on the other hand, are unraveling the fundamental principles underlying light-paper interactions, paving the way for breakthroughs in areas such as photonic devices and renewable energy technologies. In essence, the study of paper exemplifies the synergistic relationship between engineering and physics. By combining their expertise, engineers and physicists can unlock the full potential of this seemingly ordinary yet profoundly impactful material, driving progress and innovation in diverse fields. As we continue to push the boundaries of knowledge and technology, let us not forget the humble origins and enduring significance of paper in shaping our world. In the realm of engineering, the history of papermaking is a testament to human ingenuity and technological advancement. The evolution of papermaking techniques, from ancient civilizations using handcrafted methods to the Industrial Revolution's introduction of mechanized processes, highlights the intersection of engineering and innovation. Engineers throughout history have refined papermaking equipment, optimizing efficiency and quality while minimizing environmental impact. Today, sustainable practices in paper production, such as recycling and alternative fiber sources, are at the forefront of engineering efforts to mitigate environmental concerns. From a physics perspective, paper serves as a fascinating subject of study due to its complex mechanical properties. Physicists delve into the microscopic structure of paper to understand the interplay of forces that govern its behavior under various conditions. Concepts such as stress, strain, and deformation provide insights into how paper responds to external forces, informing the design of more resilient materials and structures. Moreover, physicists explore the optical properties of paper, elucidating phenomena such as light absorption, reflection, and scattering, which have implications for industries ranging from printing to renewable energy. Examining the historical context of paper reveals its profound impact on human civilization. Originating in ancient China around the 2nd century BCE, paper revolutionized communication, commerce, and the education, facilitating the exchange of ideas and knowledge across cultures and continents. The spread of papermaking techniques along trade routes fueled the rise of literacy and intellectual pursuits, laying the groundwork for scientific and technological advancements in subsequent centuries. Today, paper remains an indispensable medium for preserving and disseminating information, bridging the gap between past and present through its enduring legacy. In conclusion, paper's significance transcends its seemingly humble nature, encompassing a rich tapestry of engineering innovation, physics exploration, and historical significance. As we continue to push the boundaries of scientific discovery and technological progress, let us not forget to appreciate the timeless relevance of this extraordinary material. Through interdisciplinary collaboration and appreciation for its intricacies, we can unlock new possibilities and ensure that paper continues to inspire generations to come. Thank you.